Hello, and welcome to the Harvard Center for International Development's Friday Speaker Series. I'm Crystal Niga, the Program and Event Coordinator here at CID. At CID, our mission is to build a thriving world for all. We work across the university and a global network of researchers and practitioners to build an international pool of talent, convene academic and practitioner networks, and deploy breakthrough research to address the world's most pressing challenges. It's why we are so excited about today's conversation on innovative dialogues on climate action via GEM Incubation Fund. Before we get started, I want to mention a few housekeeping items. Please enjoy lunch, but help the planet by doing your part. All food items, including cups, napkins, and utensils, are compostable. Please hold all questions for our speaker until they have finished the presentation and have opened the Q&A section. At this time, I will go around with a mic so we can hear you clearly. We are recording today's session, which is on the record, but we'll keep the camera on the speaker, only ensuring that only voices from the audience will be recorded. The video of this event will be available on CID's YouTube channel afterwards. A CID member may take photos of the event for use on CID's social media channels. If you are not comfortable with your photo being used this way, please let a CID team member know. Please use the QR codes located around the room to check into today's event. This helps the CID team track attendance and cater future events for the audience. Without further ado, over to Professor Joe Aldy, who will be moderating this discussion and introducing our GEM Incubation Fund speaker and awardee, Inés Camilloni. Thank you all for being here, and Professor Aldy, over to you.
Great. Thank you, Crystal. Thank you all for joining us today. It's a pleasure to be here, and it's a pleasure to talk about the intersection of climate change and development. I think, as we all know, that as the planet is experiencing climate change, the climate is changing. Where we will realize some of the most severe and serious impacts first are in many developing countries. We recognize that in part because of just the nature of the geography and where the climate change is occurring. We recognize that as well when we think about the available resources to help try to mitigate some of those risks, to try to enhance the resilience to a changing climate that may be more limited in some developing country contexts. It's because of the concerns about climate change and what they may mean for those living in developing countries that I was excited to be invited by our colleagues at CID 2 years ago at GEM 23 to be a part of the Climate and Development Global Empowerment meeting we had in May of that year. In that session, over the course of that workshop, we had a number of conversations about the intersection of climate and development, both trying to identify some of the challenges, but exploring various ways of trying to address the risk of a changing climate in developing country contexts. I was also excited about the fact that one of the topics that we took on is one that is slowly emerging in policy debates. It's one where there is still quite exciting research to be undertaken, where as we learned something new today, it's really advancing much more faster our understanding of this as a potential strategy for mitigating climate change. What I'm talking about here is the concept of solar geoengineering or solar radiation modification. We had discussions with a number of experts, including our guest here today, who I'll introduce in just a moment, with various academics and practitioners at that Global Empowerment meeting to talk about what solar geoengineering might mean, how we might think about its potential in mitigating some of the risks of climate change, and how that should inform our policy discussions. Now, since then, we've seen this issue gain a little bit more resonance in some of the policy debates. Last year, a commission, the so-called Overshoot Commission, looked at a number of different kinds of strategies, drawing on expertise across people who used to be heads of state, heads of foreign ministries, finance ministries, leading academics, leading practitioners who led environmental groups in civil society, all trying to think about what we do to address what may be the coming so-called overshoot. This concern that while we have set ambitious goals in the international climate negotiations, aspiring to limit warming to no more than 1.5 degrees C relative to pre-industrial levels, to also to limit warming by less than meaningfully below 2 degrees C relative to pre-industrial levels. Those are sort of the two goals in the Paris Agreement. I think as many of you know, last year globally, we were about 1.5 degrees C above pre-industrial levels. There's concerns that we are now starting to move into this period where, because of our failure to adequately reduce greenhouse gas emissions, we're going to experience warmer and warmer temperatures and the associated adverse impacts from those warmer temperatures. So the strategy of solar geoengineering, and specifically the idea that we may put particles into the upper atmosphere to deflect incoming sunlight to cool the planet, is one that the Overshoot Commission explicitly addressed and thought we need to better understand this from both a research perspective and a governance perspective. And it's one that we are seeing more and more scholars in academia start to look at and engage to see whether or not it could be a plausible strategy among a mix of strategies to address climate change risk down the line. As a part of that, then, in the GEM Incubation Fund, we support what we think is path-breaking research that's at the intersection of both scholarship and applied practice. The Incubation Fund supports research aligned with the theme of that year's meeting. So after the 2023 meeting, we solicited proposals for the fund, and very excited to be able to support a project led by Inés Camilloni. So Inés is joining us today from Buenos Aires. Inés is a professor in the Department of Atmospheric and Oceanic Sciences at the University of Buenos Aires, and she has led a project exploring this issue of solar radiation modification in a distinctive way that we haven't seen yet in the literature. She decided to focus on this in the context not of what's the impact on global temperatures, or maybe what's the impact on large regions, but instead, what's the impact on a large urban setting? And in this case, it's Buenos Aires. So Inés, let me turn to you. I've talked enough here to set this up. We'd love to hear a little bit about your project first, and then I'll follow up with a few questions before we open it up to questions from the audience. So Inés, welcome to our seminar today.
Okay, thank you, Joe, and thank you for the invitation to participate in this conversation with you. And yes, my project that it has PhD students from the University of Buenos Aires, and also we have the collaboration of Daniele Visioni from US, and also Andy Parker. We are an international team, but based in Buenos Aires, in Argentina. And as you mentioned, the focus of our project is Buenos Aires, that is the capital of Argentina, and is one of the largest megacities that we have in Latin America. It's home for from over 14 million people. That this means nearly 1/3 of the Argentina's population, and it's also a central part of the country in terms of the political, economic, and cultural activities we have in this city. But as many other cities in the world, we are increasingly vulnerable to many climate change related risks. In this case, and for Buenos Aires, the main hazards are heat waves, the increase in frequency, intensity, and more long-lasting heat waves, heavy rainfall that can produce large floods in the city, and also another important hazard is the coastal flooding because of the rising of the La Plata River level that is connected to the Atlantic Ocean. So as climate change continues to intensify, it's important to us to understand the different possibilities and strategies we may have to reduce these vulnerabilities to climate change. And among the different approaches emerge the possibility to the deployment of solar radiation modification at global scale that may have some impacts, some benefits, or some risk, we don't know yet, at local scale. So this is the objective of our project. We really want to assess these potential benefits and risk of solar radiation modification, at urban scale, at the Buenos Aires urban scale, in this context of being Buenos Aires one of the largest Latin American megacities, and also it's the first city in Latin America to explore the potential impacts of the deployment of this kind of technologies. And as you mentioned, we are studying the impacts of SRM in terms of one of the technologies. This technology is related to introducing aerosols into the stratosphere, the so-called stratospheric aerosol injection strategy. And what we want to explore are the potential impacts of this technology against the impacts of increasing levels of CO2 into the atmosphere. And we are doing this using a risk framework just to compare these two potential scenarios, one using solar radiation modification and the other one associated to these increasing levels of greenhouse gases into the atmosphere. And by using this risk framework, what we think is that we can provide a more local and information to policymakers with this urban perspective for a large Latin American city as Buenos Aires.
Right. So Inés, when we talk about solar radiation modification, as you noted, we're talking about putting particles into the upper stratosphere. The sort of inspiration for that is what we've witnessed, what happens sometimes in nature, when we see large volcanic eruptions, shoot sulfur particles in the atmosphere, have had a cooling effect. In fact, in some cases, if it's a large enough volcanic eruption, a cooling effect that may be global, that may span months or even a year or two, like what we saw with Mount Pinatubo more than 30 years ago. But the key thing about solar radiation modification, and specifically injecting aerosols in the atmosphere, it's not just reversing climate change. It can offset some climate change impacts, but it's not like we're simply rolling back the dial from what we've done by adding greenhouse gases to the atmosphere. So as you noted, there's some benefits, but there may also be some risk, and you're using a risk framework. Help us identify, in the context of Buenos Aires, what some of the benefits may be, and then discuss what may be some unintended risk or consequences that either may apply to Buenos Aires or may apply elsewhere that are discussed in the context of this literature.
Yes, the basic ideas you mentioned of stratospheric aerosol injection is to mimic the effect of volcanic eruptions. Now the information we have is how the atmosphere and internal climate responds to this kind of natural process, a volcanic eruption, by introducing sulfates into the atmosphere. So with climate models, we can try to reproduce this effect just to have an idea of how the climate could evolve in terms of deliberately introducing these aerosols into the stratosphere. So we are using climate simulations to address the potential impacts in our region. As you mentioned, we can identify some benefits. For example, what we expect is to lower global temperature, but also to lower temperature at local scale. This is what we found. We can expect a reduction in minimum and maximum temperatures in our region, in extreme minimums and extreme maximums, and a reduction in the frequency of heat waves, and also changes in precipitation. And these are some of the climate impacts. But as you mentioned, the idea of using this kind of technology is not to go back to the climate we used to have, for example, 40 or 50 years ago, but it means that in a way we will create a new climate, and this is why we really need to address the potential benefits and risks, and maybe there could be some unintended risks that we really need to identify to help to make a decision about the potential deployment and also the governance of this kind of technology. And in particular, the impacts in a large populated region as urban areas, these potential benefits or risks are key elements to identify and to quantify to help to make a decision about the use of this technology.
So Inés, can you give us maybe a few statistics, a few key points in terms of the impact on temperature? That's at least struck me when looking at where your research is right now, specifically the impact on temperature in BA between now and 2050, as well as longer term.
For example, to answer this question, first, I think I will need to explain what kind of simulations we are using, because the answer depends on the scenarios we are considering. We are using simulations from a climate model called, simulations are called ARISE, and these simulations are intended to keep global temperature at the most ambitious Paris Agreement temperature target, 1.5 degrees compared to the pre-industrial levels. And this is one of the simulations. And the other simulation is with the same climate model, but considering an increasing levels of CO2 into the atmosphere in a moderate scenario. In some way, the same scenario, the same track we are now in terms of emissions of CO2. This is the so-called SSP 4.5 scenario. This is not the most optimistic scenario, but it's not the worst one. It's an intermediate one. So what we are trying to do is to compare the effects under these two different scenarios that we can keep these 1.5 degrees levels according to the Paris Agreement, and this intermediate scenario where we are not doing what we need to reach this temperature goal. And in these terms, what we can expect, for example, is a reduction in the maximum temperature of 1.4 degrees for the midterm. So this will reduce this extreme temperature in Buenos Aires in terms of the impacts of CO2 into the atmosphere. And this is quite important because considering that in urban areas, we not only have the effects of anthropogenic climate change associated to this increase in the concentrations of greenhouse gases into the atmosphere, but also we have local effects associated to, for example, the urban activities and that produce the urban heat islands. So any reduction in extreme temperatures, it's really a benefit in terms of the population of the city that, as I mentioned, is over 10 million people.
So you're finding over about the period of 2055 to 2070 that a solar geoengineering intervention, putting aerosols into the stratosphere, could reduce temperatures about 1.4 C relative to what they would be otherwise, which is kind of like saying right now we've experienced 1.5 degrees C of warming. There will be more warming as we continue to accumulate greenhouse gases in the atmosphere. But that there's this potential that you could have a solar geoengineering intervention that would keep us from basically doubling in BA the temperature impact. Is that about right? We'd go from 1.5 to another 1.4 without solar geoengineering?
Yes, that's right.
And the one thing I would like to stress as we sort of think about this as a strategy for managing temperatures is that the sort of historic focus of international efforts, national efforts, subnational efforts to address climate change has, dating back to the 1990s, focused on cutting greenhouse gas emissions. It makes a lot of sense. You cut greenhouse gas emissions, you can prevent the problem from happening. The problem is we haven't cut our emissions enough. The other problem is that we're dealing with what we scientists and economists would call a stock problem. It's not the flow of emissions that matters, it's the total amount of greenhouse gases that have accumulated in the atmosphere that matters for the warming. So even if we're really successful over the next several decades globally in reducing our emissions, even if net emissions globally are still going up by 2050 or 2060, which even with all the goals to go to net zero by 2050 or 2060 or 2070 made by other various major economies, and we're in one right now that is backing away from that goal, but we would still be globally net positive by 2050, it means we're still going to be getting warmer. Maybe not as warm as we would have without all that effort, but in the near term, if we really think about the potential risk of a warmer planet, of the heat stress that Inés talked about, of how it might sort of turbocharge, if you will, the hydrologic system and increase the amount of precipitation in some places or decrease it in others. These kinds of impacts that occur, cutting emissions even dramatically over the next several decades, so long as globally we're still adding the stock in the atmosphere, means we're just slowing growth in temperatures as opposed to reversing it. And when we think about the strategies to actually reverse and start cooling globally from where we are today or where we may be in 10 or 20 years, solar geoengineering is one of the few tools we see that we may have at our disposal to be able to deliver that kind of near-term impact. And I think that's one reason why it is starting to draw some attention among policymakers. Now, Inés, on that point on policymakers, I'd like to turn to you. You're doing this work focused on BA, understanding the impact on temperatures. You've been doing modeling work to understand the impact on precipitation, how that may affect flood risk. How have you, or how will you, if it's coming up in the next stage of your work, engaged the leaders in the city government and in the national government about what you are learning from this research?
What we expect to do is to have a conversation at local level with the city government, because in 2019, we already have a workshop in Buenos Aires, and at that moment funded by Degrees, an NGO that funds research for developing countries to explore the potential impacts of SRM. And at that moment, in this workshop we had for 5 years ago, we invited people from from the national level and at governance level, and also from the city of Buenos Aires, and also academics and different NGOs. And in particular, the city of Buenos Aires was interested about this project and the analysis of the potential impacts at this stage. And also I'm part of the climate change advisory committee of the city, and this in some way helps to have a more easy conversation with the local government. So what we are planning is to have a new workshop this year when we have more results of this project to present these findings at this local level, and to introduce them in the new information there's available about this technology, the impacts, and also the new governance discussions that there have been occurring during these years, and also some ethical conversations about the potential deployment of this, because in some ways cities are well organized in climate change conversation, and it's sometimes easier to have this conversation and avoiding some changes at national levels related to climate change policies. At least this is what happens now in Argentina, that it's easier to have this conversation at local level. So it's good that our project is just focused at the city level of Buenos Aires.
Great. So I want to go to the audience for questions in just a moment, but I want to follow up on this this last point about having these conversations locally, and how, as an academic and a scientist, how you're effective in doing this. I will note and reflect on my own experience. There are times when I've had conversations with individuals about this as a strategy for addressing climate change. They think it's science fiction. The idea that we would actually manipulate the entire planet this way by putting particles to block some of the incoming sunlight just seems like part of like a movie that we'd expect out of Hollywood, not as part of a portfolio of actions to address climate change. And I can also imagine when you're having this conversation with city leaders, there's the question of, well, we would understand these impacts, but how do we voice our interests and our preferences about this for those who might consider this as a technological option down the road? An individual city is not going to launch an intervention to put aerosols into the stratosphere. So I'd love to hear a little bit from your experience about how to communicate with people who are interested in working on climate about this relatively new strategy. And then how do you talk about city leaders about something which may matter for them, but they don't directly control its implementation?
In my experience, I think it's important to show them the big picture on the solar radiation modification conversation. That this is not now only at the academic level, that there are increasing conversations related to the governance or more dialogues on science policy related to solar radiation modification at a really very high level. As you mentioned, the Climate Overshoot Commission has mentioned this. The Intergovernmental Panel on Climate Change also included in the assessment that will start soon in the outlines, that the outlines were approved by the governments, the consideration of solar radiation modification, and not only from the physical science view, but also from the impacts and vulnerability view, considering governance and ethics on this technology. And so in that way, governance and governments are really involved in this conversation. And next month, there will be also a dialogue, science policy dialogue on solar radiation modification, a high-level dialogue at the World Meteorological Organizations, sponsored not only by this organization, but also by UNEP. So when you show that this is not something that a small number of researchers are thinking about and doing some modeling, but there are some high-level conversation at different renowned organizations out there, they start to listen more, at least they are more interested to learn about this. Also, it's clear that this is not a technology that not only a single city, but even a developing country, or at least a country like Argentina, has the opportunity to decide to deploy it by itself or not. It depends mostly on other countries. But at least they try to realize that they really need to have a voice in any conversation about the deployment of this technology. And to do that, they really need also to understand the impacts, the benefits, and who will make a decision and who will decide to cool the planet to what level, to which level, 1.5, 2 degrees, and for how long do you need this technology, and these kind of things, and if this, for example, technology could have some impacts on the generation of, for example, solar energy in our region, they start to become more interested in this.
Great, thank you, Inés. Let me open it up for questions from the audience. Crystal will go around with a microphone. So if you would like to chime in with a question or a comment, please raise your hand.
Hi, thank you so much for coming to speak with us. By the way, this has been super informative, super interesting. Forgive me if this is a very elementary question, because I am not very familiar or like not an expert on the topic at all, but like I've heard that this can potentially reduce crop yields, especially like in the tropical areas. So, and I feel like I can see the big benefits for cities in terms of reducing heat waves and things like that. How would you speak to farmers globally about this issue, like, and the, benefits in cities compared to the benefits in rural areas? And obviously, big cities depend on food and
Right.
crop yields. Yeah.
Great. Thank you. Inés, you want to
Thank
take that
you.
question?
I have not an answer for that because I don't think science already has an answer to say how food production could change for better or worse in terms of deployment of this kind of technology. This is why we need more research also in developing countries that have in some cases a really relevant role in food production. But to do this, we also need not single researchers doing the assessment on how one yield can change in one region. We need some kind of coordination to have this information using the same kind, for example, of scenarios and simulations to produce this big picture of how food production could change under the potential deployment of solar radiation modification.
Yeah, I think it's a really important question. I mean, when we think about climate change, one of the big risks is what will it do to food production around the world? And what impact does that have, especially in some places where they rely a lot on local production to meet the calorie and nutrition needs of the local population? What does it mean in terms of how it may spill over into markets more generally, where if there's an adverse shock to production of a key grain in one area, it raises the price everywhere else around the planet and makes it all the more expensive, especially for lower income households where food may be a larger fraction of their budget. What we see with climate change is a need for farmers to adapt. The climate, to be specific, the weather that reflects the climate goes into the production function of agriculture. When it rains, we're using that water on our crops. The temperatures, as the season warms and we go into the growing season, will affect our ability to produce. We already see farmers adapting to climate change. We see that in terms of when they are planting. We see that in how they manage water, where they have the ability through irrigation to control and manage water. We see that with innovation with seed varieties that are trying to be more heat resistant or more drought resistant. We're also finding that there's limits to that. We know that there are certain temperatures where a lot of the key grains in the world, from a calorie standpoint, really lose productivity dramatically at exposure to high levels of heat stress. There has been some research, but as Inés noticed, it's, I think, a pretty short literature and incomplete and mixed about whether, there's some research suggesting that after Mount Pinatubo, it had an adverse impact on agricultural production. I think a lot more needs to be done there. I think this is also a sign, though, about how we need to be cautious about how we interpret lessons from that kind of experiment. There's something very different from an unexpected volcanic eruption that may have had an impact on productivity in agriculture the subsequent year versus something which you might be planning over the course of the next several decades that might give you time to then induce that kind of innovation in agriculture, in the agricultural industry, to be able to better manage that effect. For that matter, Inés also noted this concern that with respect to solar power, that if we're reducing just a little bit of the solar radiation coming to the surface, we may lose a little bit of productivity from our solar panels. The difference here is pretty modest, but there is a concern that we might pick some of this up. It may change wind patterns when we do solar geoengineering in some places, because we're changing the energy balance. That it may have implications for where we site wind farms and how productive they are. Things are going to change. The key thing is, as Inés noted at the beginning, because of climate change, things are changing. And the question here really is trying to assess and identify those risks of a world in which climate change is continuing to occur, and a world in which you might consider solar geoengineering as part of your suite of strategies for mitigating climate change. And Inés, being a very good scientist, thinks, and I agree with her, also as an academic, we need more research. But it's not sort of self-serving. It's something where we know this is something that is potentially very important and where our knowledge base is too thin. And it's one of the things that frustrates me right now when I look at what's happening in the US government with respect to climate research and pulling back the climate research. We need to better understand these impacts. And that kind of knowledge is useful not just for us here, but as we share it with others around the world. You know, as Inés undertakes her research in BA, we will benefit from that. And others in large cities, whether it's in Latin America or elsewhere, will learn and benefit from the research that she and her team are undertaking there to understand the impacts of how we might mitigate some of the warming of a changing climate with solar radiation modification. Let me go to another question here, please. Yes.
Hi, thank you for your talk. Oh, oof. Sorry. Um, uh, this is a topic that's new to me as well, and I was curious about what are the immediate effects of specifically aerosol injections to the areas surrounding the injected site. Um, is there an amount of disturbance there from existing research, or otherwise? And I have another question that's perhaps less serious and maybe more towards the sci-fi side. Do you see a potential future where we might have to simulate a volcanic winter to survive? Yeah.
So let me turn to the atmospheric scientist, Inés, for this question.
Yes, there are different studies and simulations considering which will or could be the best latitudes and longitudes to introduce these aerosols into the stratosphere. And there's no a clear decision about this, but it seems that some latitudes in the tropical regions could be the relevant areas. But this really does not produce a local effect in the introduction. These particles are or would be released at around 20 kilometers height into the stratosphere. So the local effects that you could feel, at least at surface, you won't see anything related to this, because the circulation of the atmosphere, the winds in the stratosphere, with disperse all these aerosols to produce this global cooling effect. So they're not local impacts at the points where you could release the particles into the stratosphere, if I understood the question correctly.
So I'll make one point and then I'll have a follow-up for you, Inés, is that for the most part, when we sort of think about this technology, it is something that can occur in the modeling frameworks that Inés implements in her lab. But we don't really have the availability today to do this kind of intervention. We're talking about flying airplanes at an altitude where not only do you have to fly that high, but then you have to be able to open up the fuselage just a little bit, have a pipe stick out. This is what happens when you have an economist, not a scientist, doing this, or an engineer. But this is how I interpret it. You have a pipe come out and it's going to shoot out a fine particle. The focus has been on sulfur, in part because of what we know from volcanic eruptions. For that matter, we also know this from when we've burned fossil fuels at ground level. That when we've burned fossil fuels historically, coal and petroleum especially, that there's some sulfur emitted because there's sulfur naturally in those fuels. When we burn them, we have some sulfur that is lower level, and we know that it's had a bit of a cooling effect. It offsets a little bit of the warming. We've done a very good job cleaning up in many parts of the world the sulfur in our coal and the sulfur in our gasoline and diesel and so on. So there's less of that sulfur pollution occurring, which is good for local population respiratory health and cardiovascular health. But it means there's a little bit of this kind of cooling effect that's no longer there associated with that. But when people sort of think about how you might, if you were to go forward with a solar radiation modification strategy, you would have to develop a new fleet of airplanes that could fly that high on a very regular basis and inject particles into the stratosphere, so really high up. Which gets to the question I have for you, Inés. When we sort of think about these local impacts, There's one that I'd love your thoughts on because it's been discussed as a potential risk of putting particles in the upper atmosphere, and that is, what impact might we have on the ozone layer? We have the stratospheric ozone layer, which has protected us here at the ground level from exposure to unhealthy levels of UV that may contribute to skin cancer, may have adverse impacts on agricultural production. We've had concerted, and I would say relatively successful efforts globally at reducing the emissions of ozone-depleting substances like chlorofluorocarbons. If we put these new particles into the atmosphere, are we concerned about what it might do to the ozone layer and our efforts to try to repair the ozone layer over the past few decades?
Yes, introducing sulfur into the stratosphere is not a good idea in terms of protecting the ozone layer. So in that sense, there are many studies that are exploring different materials to replace the sulfur in this stratospheric aerosol injection. So, and there are many studies about the potential negative impacts of this technology on the ozone layer, but there are, on the other side, many studies exploring different alternative materials to replace them.
Great. In fact, I'll make a plug here for a colleague's work. Frank Koich, over in the School of Engineering and Applied Sciences. Frank, someone who Inés knows. He and some colleagues have done some work recently trying to look at some of these other materials that don't have the same adverse side effects of sulfur, but can still play a key role potentially in helping to cool the planet if we were to inject them into the stratosphere. If you want to get a little bit of an exposure to that research, you can go to the Harvard Climate blog. The Salada Institute for Climate and Sustainability at Harvard, our university-wide climate institute, now has this weekly blog. And we have from just a few weeks ago, Frank wrote a short post about this. So that'll give you a little bit of an introduction to this work, and it provides a link if you really want to dig into the research papers. Then you can also get an entry into that research through that blog post. Any other questions from the audience right now? Yes, please.
Hi, thank you for your presentation. So my question is around, this seems, I've had no idea about anything on the topic, so very innovative and as a way to combat climate change. And there's such a backlash of the topic now, but also misinformation. So how do you move forward with this work that is so important in terms of something that's going to be impacting and is impacting everybody around the world? How do you communicate it to individuals so that you fight this misinformation and disinformation that's occurring, because it's so key in moving forward?
Inés.
Yes, it's not easy. At least the situation in my country related to climate change science and climate change funding for research is quite difficult. But anyway, we keep doing our research. At least at universities, we have the chance to continue with this. But voices against the science of climate change are rising, as you mentioned. But what we are trying to do is to work together with science communicators. There are people specialized in climate change communications, and we are trying to work all together, trying to answer these misinformations that appear everywhere, not only in the social media, but also in newspapers. And there are many voices against the science. And what we are trying also to do is to fund to base our the information we try to communicate in very strong and the agreed information we may have from renowned organizations like the IPCC, as I mentioned before, this intergovernmental panel on climate change that periodically produces reports that are approved by governments. And at this stage, this is what we can say. Well, this is what IPCC is saying, and the IPCC is, at the end of the day, are the governments. So this is what we are trying to do to navigate these difficult days.
I would just say it's a very important question. It's much more than just a technical issue, obviously. I mean, a lot of this is going to be necessary for us to improve our understanding through the scientific research that Inés and other scholars are undertaking. So we have that technical foundation to inform a policy debate, but we're already seeing it's almost kind of an extension of some of the sort of the conspiracies that we see in other contexts are actually being aired in this context, where people think the government is already controlling the climate in a way similar to how one might think about a solar geoengineering intervention. So there's already that kind of, I think, concern about whether, as this research continues, how to communicate effectively what we know and don't know. I mean, that's some of the challenges. As an academic, as a scholar, it's sometimes important to be humble and to characterize uncertainty. Policymakers don't necessarily want to understand uncertainty. They want to say, what do we know? What can I do? And trying to characterize uncertainty, which may create space for conspiracy theories, actually is something, that kind of ambiguity is something a policymaker would typically like to avoid. But I think this question raises the important issue about how we create the space to go from the scientific scholarship and the rigorous evidence to how it informs a social and political conversation about what we can do next and should do next to address a changing climate. We have time for one more question. So I want to see if anyone else has a question. I have a question, but I want to see if anyone else has a question before I jump in with my last question for Inés. Okay, I'm jumping in. So Inés, you mentioned degrees, and you mentioned Andy Parker as a colleague in this. I'd like to hear a little bit more about what Degrees is doing, and importantly, why you see that there's value in building up the capacity in developing countries among its experts working on this issue, and how it can inform the publics and the policymakers in developing countries to engage more effectively on this issue in the future.
The importance of degrees is that they fund research in developing countries to explore the potential impacts and raise and potential benefits or co-benefits or trade-offs about the potential deployment of solar radiation modification. But they are doing this in some coordinated way and trying to produce research that we can compare among the different regions, just to try to have some kind of atlas about the impacts in different regions of this technology, just to have a more big picture idea of the impacts of solar radiation modification, not only single studies around different developing countries in the world. And they also promote the North-South collaboration. This is why, for example, I'm collaborating with Daniele Visioni from Cornell University. They are doing the climate simulations we are using in our research. And we are having monthly meetings to discuss our projects, but we are studying not only the physical impacts of solar radiation modification or impacts in different regions, but also they have social political research doing also by different groups in different developing countries in the world. And we are having also this dialogue between the physical scientists and also the social scientists too. So, and Degrees have been doing this for at least 6 or 7 years up to now. And next month, they are organizing the Degrees Global Forum in South Africa to bring everybody that is working on this, from the people that in some way could be more close to promote the use of this technology, to other people that is completely against, because they think that this could in some way slow the need of the reduction in CO2 emissions and also in the other greenhouse gases. And the idea is to bring everybody together to have 4 days for discussions, and also policymakers will be participating, many of them from developing countries. So I think they are doing really very relevant work on producing research and communicating, and also involving different sectors in this conversation.
Great, thank you, Inés. But before we wrap up, as a reminder, this is work that Inés has been talking about, supported through the GEM Incubation Fund from the Global Empowerment Meeting we had in 2023. The next Global Empowerment Meeting is later this month. We'll focus on the role of AI for more inclusive growth. So check that out. Finally, please join me in thanking Inés Camilloni for her presentation today. Thank you so much, Inés. It's great to see you.
Thank you. Thank you.